So one of the most common questions in mathematics that you're going to come across from 12-year-olds that don't want to be in the classroom is, when will I ever use this in real life? When will this ever be applicable in real life? And it's not so much the Pythagorean theorem that you're going to be using in real life, or it's not the equations of derivatives or the equations that you use to find integrals, but rather the concepts in which they are delivered upon, right? You're able to kind of visualize different things out of learning these various concepts. So let's say, for example, we have an equation x squared plus 2x plus, I don't know, 10, right? Random equation. So first, let's talk about slope. Slope is when we have a linear equation that produces a line like this, we say that the slope is positive because it goes up as it goes to the right. And we similarly, if we have a line that goes down as it travels to the right, it has a negative slope. And if we have a line that goes completely flat, I know that's kind of going down, but let's imagine that this is completely flat. It's parallel to these lines here. It's flat, the slope is 0. Finally, if we have a line that goes up and down, and it doesn't travel to the left or to the right, the slope is said to be undefined. Because it is not going up to the right, it's not going down to the right. It is going straight up and straight down, because usually this means that we have an equation that looks like x equals, I don't know, 5, right? And that produces an undefined slope. So now, if we have a graph that produces this shape, what is the slope of this line? It's kind of tricky, right? But we do know the slopes of various points of this function. Like, we could say from this point to this point, the slope is positive. The point from here to here, that's negative. And over here, it's positive again, right? And this brings us to our next point, is the tangent line and the slope of the tangent line. So if we have a tangent line, is when you have one point on the function and we draw a line such that it only touches that one point on the graph. Okay? So let's say we have the tangent line for the point right here. Okay? We're going to draw a line such that it only touches the function or the graph at that point only. All right, let's just imagine that it's touching it there. We'll notice that the slope is positive. Furthermore, if we draw another tangent line, let's pick, I don't know, randomly right here. Yeah, like right there. We'll notice that the slope is negative. Right? It's going down as it goes to the right. Similarly, just like the first one, if we pick another point like right here, right? Slope is positive. It goes to the right as it goes up as it goes to the right. Now what about right here? We pick the point right here at the peak. What is the slope? What will the tangent line of that point be? What is the slope of that tangent line? Much rather. What is the slope of the tangent line at this point? Now, if you'll notice, at this point, the graph isn't going up and it's not going down. So therefore, the line is going to be perfectly horizontal, giving it a 0 slope. Similarly, when we draw the tangent line at this point right here, we'll notice that it is also perfectly flat, meaning that it is also 0 down there. Now, the slope of a line is represented by the equation mx plus b, right? And the slope of a tangent line on a given graph is represented by the derivative. So when we find the derivative, we are able to plug in values and we're able to solve the derivative, which will produce the coordinates of the highest point of the graph, the maximums or the minimums of the graph. So let's go back to our equation, x squared plus 2x plus 10. Now if we find the derivative, set it equal to 0, we will discover the x coordinate that represents where the maximum lives. So let's start by taking the derivative. The derivative of x squared, we're going to move that exponent to the front and then subtract 1 from it and leave that difference in the exponent. So x squared, we move the 2 to the front, 2x. 2 minus 1 is 1, so we leave just 1 right here, or we can leave it like that. 2x, okay? Then the derivative of 2x, since there's a 1 there already, we're going to subtract 1. We multiply it by the 2. 1 times 2 is just 2. Okay, and then 1 minus 1 is 0. So now we have, our new equation is going to be 2x to the 0 power. X to the 0 power, anything to the 0 power is 1. So this becomes 2 times 1, which is just 2. Okay, so our function, f of x, was x squared plus 2x plus 10. Our derivative, which is represented by f prime of x, equals 2x plus 2. Now, like I said earlier, we're going to set the derivative equal to 0. 2x plus 2 equals 0, and we just solve it like a system of equations or whatever. Minus 2, which gives us a new equation, 2x equals negative 2. We divide both sides by 2, which singles out the x. X equals negative 2 divided by 2 is negative 1. Okay, so now we're almost done. The maximum or minimum value, it lives on x equals negative 1, meaning that when we plug in negative 1 into our original function, it's going to produce our maximum or minimum. So now let's do that. Negative 1 squared is 1, because a negative times a negative gives you a positive. 2 times negative 1 is negative 2. And then and then just plus 10. Because there's no x there, we don't have to multiply nothing. So now 1 minus 2 is going to be negative 1. Negative 1 plus 10 is 9. Okay, so now what do we have here? We have y equals 9, x equals negative 1. Now here's a little trick. When we have x squared plus 2x plus 10, the highest power, if it's squared like that, when it's x squared, and if it's positive, that means that the graph is going to look like this. Okay, it's a parabola. And because we're finding the slope of the tangent line and we set it equal to 0, when the slope is 0, as you recall, it's going to be when the line is flat. So this represents a minimum value at this point. Furthermore, when we have a negative x squared, or negative, I don't know, any negative number, it's going to be, the parabola, it flips upside down because it's a negative, meaning that it's going to produce a maximum value when the slope of the tangent line is 0. So because it is, because the degree is even, meaning that this number is even, and it's positive, it's going to produce a parabola like this, giving us a minimum value. So meaning the maximum does not exist, because there is no maximum here. Because if it's going to go on for infinity, and infinity cannot be represented numerically, therefore it's not defined. There is no value for the maximum. However, our minimum is going to be 9. And we could double check by plugging in the original function into our graphing calculator. So we have x squared plus 2x plus 10. Okay, we click graph. And as we can see, we have the minimum value right there. And we could zoom out just a bit. See, it goes and then it dips, producing a minimum value. And we could double check where that minimum value is by pulling up our table of values. And as x increases, right, we will notice that our y value, it's a very high number, and as x increases, it's increasing as we scroll down. It goes all the way, it keeps going down, down, down until it goes to 9, and then the y value increases back up to 10, 13, 18, 25, 34, 45, meaning that at x equals negative 1, y equals 9, that is the minimum value. If you have any questions, let me know.